Hello everyone and welcome back to my YouTube channel. Today we will discuss Hoffmann Ammonolysis. In previous two lectures we have prepared primary, secondary and tertiary amine. Now this is a special type of reaction in which a mixture of amines is formed. So as the name indicates, Hoffmann Ammonolysis, involvement of ammonia is there. So this is the reaction of alkyl halide with the basic solution of ammonia. So in this reaction, alkyl halide is heated with basic solution of ammonia at 373 Kelvin. As a result, NSR reaction takes place and we obtain a primary amine, and byproduct is a strong acid. That's why we require basic solution of ammonia. This base will neutralize the effect of HI, otherwise reaction will be reversible. So now this primary amine formed, it further reacts with the alkyl iodide to give a secondary amine. So the primary amine formed, it further reacts with the alkyl iodide to form secondary, to prepare to give secondary amine, plus byproduct is hydrogen iodide. So this is secondary amine. Now this secondary amine again further reacts with the alkyl iodide . So now we have by the reaction of secondary amine with the alkyl iodide, we have a tertiary amine, and byproduct is again hydrogen iodide. Now we can see still there is a lone pair on nitrogen, so this nitrogen will react with this, this lone pair will be given to another molecules of alkyl iodide. As a result, quaternary salt is formed. And now at final step we have a quaternary salt. At this step reaction will stop. So this is the mixture of primary amine, secondary amine, tertiary amine and a quaternary salt. So what is the mechanism of this reaction? Let us understand the reaction with the mechanism. Mechanism involves the attack of ammonia through lone pair on alkyl iodide, alkyl halide. We have Rx molecule, so attack takes place by lone pair of ammonia. Actually it is a SN2 mechanism. So by SN2 mechanism, lone pair of ammonia, nitrogen attacks on alkyl halide. As a result, primary amine salt is formed. If this lone pair attack on alkyl group, this pi bond will shift towards halogen. So as a result, primary amine salt is formed. This primary amine salt is further reacted with ammonia so primary amine salt further reacts with ammonia to give primary amine and ammonium halide is formed. So now we have a primary amine here and still lone pair is present in a primary amine on nitrogen atom, so it will act as a nucleophile. It will attack another molecules of alkyl halide. So now we have a secondary amine salt. Again, second step is common. It will further react with ammonia. So now we have a secondary amine. In first step we have a primary amine. Still reaction will further proceed by the attack of a lone pair of nitrogen on alkyl halide again. So now we have tertiary amine step, tertiary amine salt. It will further react with ammonia to give tertiary amine and ammonium halide. Still lone pair is there on nitrogen, so it will further react with the alkyl halide, attack on RX. So in final step we will obtain a quaternary salt. So this is the mechanism initiated with the attack of a lone pair of nitrogen towards RX by SN2 mechanism. So we obtain primary amine salt, which is further reacted with ammonia to give primary amine. Now in this step, lone pair of nitrogen act as a nucleophile and it will attack on another molecules of RX. So second step repeated again, we obtain secondary and so on, tertiary and quaternary. But this reaction is not preferred to prepare amine. Why? Because a mixture of amines is formed and it is not easy to separate them, primary, secondary, tertiary and quaternary. So this method is not suitable to prepare amines. Why? Because a mixture of amines is formed and we can't easily separate them. Second limitation, aromatic compounds can't be prepared by this method. Why? As compared to alkyl halide, aryl halides are less reactive due to resonance, where there is a partial double bond character. So there is a partial double bond character, so they are more stable or less reactive. So the bond of carbon halogen will not be cleaved by ammonia. So aromatic compounds or aniline can't be prepared by Hoffmann ammonolysis. Only alkyl amines are formed. Why? Because this bond is weak bond as compared to carbon halogen bond in aromatic compounds. This bond is having partially double bond character, and resonance is there. Due to resonance, extra stability is there. That's why we can't prepare aromatic compounds or aromatic amines, or simply aniline can't be prepared by this method. So it has two limitations. One, a mixture of amines is formed which can't be further separated easily. Second, aniline or other aromatic amines can't be prepared by this method, right? But we can stop this reaction in one step also. If ammonia is taken in excess, then reaction is completed in one step only. We can prepare primary amines. Due to excess quantity of ammonia, reaction will complete in one step, right? All the molecules of Rx will be attacked by ammonia. As a result, all the molecules will change to primary amines. There will be no more Rx molecule will left. No more Rx. That's why reaction will be completed in one step. Primary amine will be the major product. No other products will form. So this is complete Hoffmann ammonolysis reaction. This method is used to prepare mixture of amines. There is a similar one more reaction in which mixture of amines is formed. In Hoffmann ammonolysis, we have used alkyl halide, and in second method we have alcohol. So reaction involves the alcohol and ammonia both in a vapor state. So in this reaction, vapors of ammonia and alcohol are passed over heated aluminium oxide at 620 Kelvin. As a result, primary amine is formed. Again, reaction is NSR reaction, nucleophilic substitution reaction. So this primary amine has lone pair. It will further react with alcohol to form a secondary amine. So we have now secondary amine. It will further proceed to react with alcohol. So again we can see we have a mixture of amines, primary, secondary and tertiary. So to make it complete in one step, we have to take ammonia in excess again. If ammonia is in excess, If ammonia is taken in excess, then all the molecules of alcohol will be attacked by ammonia, and as a reaction will take place, and reaction will complete in a one step, and we will have only primary amines. So by Hoffmann ammonolysis and by ammonolysis of alcohol, we can prepare primary amines if ammonia is taken in excess. If ammonia is not in excess, then in both reaction mixture of amines is formed. That's why both methods are not preferable to prepare amines. There is a limitation of both reactions. So that is the complete for preparation of amines. In next segment we will start physical and chemical properties of amines.